Hey, we're going to have a quick discussion today, a little bit more about randomness and also a little introduction to probability. So back on randomness here, a random phenomenon is when we know what could possibly happen. We know all the possible outcomes, but we're not sure what is actually going to happen. So a few vocabulary words. When we do something that's a random phenomenon, let's say, for example, flipping a coin, each time we observe the random phenomenon, that's called a trial. So every coin flip, where we could either get a head or a tail, they each have the same chance of landing face up, and so it's completely random which one we get, and so each time we flip it, that's called a trial. The outcome is the value that we get each trial. So after flipping the coin, whether we get a head or a tail, that would be the outcome of the trial, which was, again, flipping the coin. An event is combining outcomes. So let's say that we flip a coin 10 times. We'd record each flip, so each trial, we would record the outcome, whether it was a head or a tail, and then combining those 10 outcomes, we can call that an event. So the event was flipping a coin 10 times, and then all of the outcomes that came from that. And then finally, the sample space is sort of the overwhelming, the big idea, and it's the collection of all possible outcomes. So if we are flipping a coin 10 times, a trial is flipping the coin. The outcome is heads or tails. The event would be 10 coin flips, where we would list all the heads, all the tails that we got. And the sample space would be all the possible ways you could flip a coin 10 times and get results. So let me do a couple examples of finding the sample space for an event. So for tossing two coins, and then we record heads and tails. So we could get a heads and then a tails. We could get a head and then a heads. We could get a tails then a heads, or we could get a tails then a tails. So there are only 4 ways to flip two coins and record what happens. I'll put them in brackets because this is a set of possible outcomes. This is the sample space for tossing two coins, recording if it lands heads or tails. Another one is having 3 children. We're looking to record the number of boys out of those 3 children. So we could have 0 boys, we could have 1, we could have 2, or we could have 3. Okay, the other thing in this question was we wanted to determine whether or not these things were equally likely. In the coin tossing, a head is equally as likely to happen as a tail, and therefore any of these 4 outcomes, heads, tails, 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 any of those events would be equally as likely to happen. For a family having 3 children, that's not as equally as likely to have 0, 1, 2, and 3. So go ahead and pause and give these 2 a shot, list the sample space, and decide whether or not you think that these events are equally likely to happen. So when I roll 2 dice with 6 sides each, and I record the larger of the 2 numbers that lands on top, I have 6 possibilities of the number that can be largest. I could have a 6, a 5, a 4, a 3, a 2, and a 1. The way that 1 would be the largest is if they were both 1 when they landed. So these events are not all equally likely to happen because there's only one way for 1 to be the largest, and there are 6 ways for 6 to be the largest. I could get 2 6s, I could get a 6 and a 5, 6 and a 4, 6 and a 3, 6 and a 2, and a 6 and a 1. So it's more likely that 6 is the larger number than 1 is the larger number. If I flip a coin until I get a head or 3 consecutive tails, well, I could flip the coin once and get a head. I could flip the coin twice, get a tail, then a head. Flip the coin 3 times, get 2 tails and a head. Or I could flip it 3 times and get 3 tails consecutively. So again, these are not as equally, excuse me, I want to pardon my grammar, equally as likely to happen. So both of these were not. That brings us to talking about the law of large numbers. I think this is something you might have a little familiarity with. So if we keep, there goes my grammar again, if we kept flipping that coin over and over and over and over and over, maybe 100, 200, 300 times, the proportion of times that one event, so let's say getting a tails, would occur, it would settle to one specific number, and we would call that the probability. And you know that if I flipped a coin 100, 200, 300 times, that I would get a tails approximately 50% of the time, and I get a heads approximately 50% of the time. So this is saying the more we do it, the larger the number of repetitions, the closer we're going to get to the probability of the event. A couple important notes. The possible outcomes cannot change for this law of large numbers to be true. So if we're flipping a coin, the outcomes are never going to change. It's either going to be a heads or a tails. And then the events need to be independent of each other. So each coin flip does not predict or does not affect the next coin flip. Okay, the coin doesn't know whether or not it landed as a tails the next time I flip it. Okay, so flipping a coin, the outcomes don't change and they're independent, so the law of large numbers applies. So let me pose a question. You've just flipped the fair coin and seen 6 heads in a row. Does the coin owe you a tails? So sometimes people talk about the law of averages, and so they think that, you know, eventually, sometimes people think if things are going right, that eventually something's going to go wrong. And so in this scenario where we have a random phenomenon of flipping a coin and we have 6 heads, you might think that, well, it's definitely going to be a tails next time. But each time you flip the coin, there's 50% chance of getting a heads, 50% chance of getting a tails. So the coin doesn't owe you a tails. You could flip a tail or a head again on the 7th time. In order to get to a place where you'd have approximately 50% of the heads and approximately 50% of the tails, you'd have to flip that coin a whole lot of times, 100, 200, 300, 1,000 times, and eventually you would get to that point. But if you've only flipped it 7 or 8 times, you could flip all heads. So here's another way to look at that. The weatherman is predicting a cold winter. Based on the knowledge of the past 5 years, there have been mild winters. So it's not appropriate to just say, based on the fact that we've had some mild winters, well, we're owed a cold winter, so it's just going to be cold because, you know, we've kind of been dodging that bullet for 5 years. Well, it's totally random, and so the weather doesn't owe us a cold winter. So you'd have to figure out other factors in play, especially with the weather. There are more scientific factors that would come into play with whether or not it was going to be a cold winter. It's not going to be cold just because it wasn't that bad for the last 5 years. So that's all I got for you today in this lesson. So introduction to talking about some probability, which we will continue. I have a few practice questions for you, and you do have a quiz Tuesday on Unit 3, so make sure you're asking any questions that you need to get answered for that.